Hey everybody, this is Gregory from Dapp University. So today I'm going to show you how to write your first blockchain application. I'll show you how to create a to-do list that's powered by Ethereum smart contracts. I'll show you how to create your first Ethereum smart contract with a Solidity programming language, or write tests against the smart contract, deploy it to a blockchain, and we'll also create a client-side application for the to-do list. So if you're new around here, be sure to subscribe to this channel and click the like button down below. And also, you can download my courses for free on my website over at dappuniversity.com/free download. I've got a link to that down in the description below. And also on my website, you can find a full-length article to accompany this video. You can actually follow that step by step as you're following this tutorial. And I've also got a link to that in the video description. So before we start actually building the application, let's get a high-level overview of how a blockchain application powered by smart contracts actually works. So how does a blockchain work? And how does a blockchain application work? Well, I've chosen a to-do list for this tutorial because that's a really common way to learn any new technology, and I want to use that to show you how a blockchain application works. So first, let's look at how a to-do list would work as a web application, and then I'll show you how it would work as a blockchain application. So I'll pull my whiteboard up here to demonstrate. So normally whenever you access a web application, like a to-do list, for example, you use a web browser and you connect to a web server over the internet. And you access, all the code and all the data from this web server. So like this, you basically connect from your web browser to the server. And on the server, it contains all the, client-side files like HTML, CSS, and JavaScript. It, contains all of the back-end code for the server, right? And business logic you might write. And any data that's stored in your application is stored in a database, right? And pretty much any other to-do list tutorial that's out there is going to show you how to write, a client-side application in HTML and CSS and JavaScript. And then it's going to show you how to basically do some business logic on a web backend that, creates, reads, writes, updates, to-dos, and then it puts them inside of a database like this, right? And all that's, on a central server. And that's how you build a to-do list on a web application. So how would you build a to-do list on a blockchain? Well, it would work a little bit differently. So instead of connecting directly to a server, we're going to access our to-do list via a browser, and we're going to, connect to a client-side application that we will build. And this will just be a simple client-side application on a web server. But this client-side application isn't going to talk to a web backend and a database. Instead, it's going to actually talk directly to the blockchain. And on the blockchain, we're going to have code that's going to be written with Ethereum smart contracts that will contain all of the business logic for our to-do list. And all the to-do items are going to be stored on the blockchain itself. And that's fundamentally how a blockchain application would work and how it's different from a traditional web application. So that might bring up a lot of questions like, well, how do we connect to a blockchain and how does the blockchain work? Like, what even is a blockchain? Well, I'll pause here and tell you a little bit more about that. So what even is a blockchain, right? Our client-side application is actually talking to a blockchain right here. So it's actually a separate network, okay? And a blockchain is a peer-to-peer network of nodes that all talk to one another. It's a distributed network. So there's actually different computers, different machines that talk to one another. And we can connect to an individual node on the blockchain in order to use it. That's what our web application is doing here. So all of the nodes on the network participate in running the network. They all contain a copy of the code on the blockchain and all of the data on the blockchain. And all of the data on the blockchain is contained in bundles of records called blocks, which are chained together to make up the blockchain. And all of the nodes on the network also participate in ensuring that the data on the blockchain, the public ledger, is secure and unchangeable. And that's what makes the blockchain so powerful. And so what about the code on the blockchain? Well, all the code on the blockchain is contained in smart contracts. So smart contracts are basically just programs that run on the blockchain. And they're going to be the building blocks of blockchain applications. And that's what we're going to build our to-do list out of. We're going to write a smart contract that will contain all the tasks in the to-do list and allow us to add new ones and complete them and things like that. So smart contracts are written in a programming language called Solidity. And all the code in the smart contract is immutable, which that means it's unchangeable. Whenever we deploy it to the blockchain, we won't be able to update that code. And that's important to understand because that's what makes the blockchain so secure. Whenever we put code on the blockchain, we know we can trust it at that point. It's called trustless for a reason. Whenever it's on the blockchain, we know that no one will change it, and therefore we know the to-do list will behave the same way every time. And sometimes I actually think about smart contracts kind of like microservices on the web. They're on the blockchain, and they read and write data from the blockchain, and they do stuff with it. They execute business logic. All right, now I'll go back to the drawing board and kind of give you a refresher about how our application is going to work. Again, we're going to connect to the application with a web browser, and we're going to build a client-side application in HTML, CSS, and JavaScript. And that client-side application is going to talk directly to the blockchain. And that's where we're going to put our smart contract. We'll create the to-do list with an Ethereum smart contract written in Solidity, and we'll compile it and deploy it to the blockchain. And we'll also connect to the blockchain network with our personal account with an Ethereum wallet in our browser. And I'll show you how to get that set up in this tutorial as well. So now we've seen how a blockchain works and how we can build our to-do list application on the blockchain. So let's jump in and start programming. Here's a preview of the application that we'll develop in this tutorial. This will be a to-do list powered by an Ethereum smart contract, where we'll be able to add new to-do items, and we'll be able to check items off of the to-do list. And before you get started, you need to make sure you have Node.js already installed on your computer. You can see if you have Node installed by going to your terminal and typing node-v. You can install Node with a package manager like Homebrew, or you can download it directly from the Node.js website. The first item in the Blockchain Developer Toolkit is a personal blockchain. We're going to use Ganache as our personal blockchain for this tutorial. You can head over to truffleframework.com/Ganache to download it. You can click this download link. And whenever you've downloaded it, make sure you install it. And when you open it, you've got a local blockchain running. So what is Ganache? What is a personal blockchain? Well, a personal blockchain is like a real blockchain network, that's connected to the public or anyone can connect to it, but it runs on a computer. It's, a closed network. And Ganache basically, is a process that runs on a computer that spins up this blockchain and runs on a server. So we can use this to develop smart contracts. We can run tests against it. We can run scripts against the network, develop applications that actually talk to this blockchain. And it's really helpful, and it's an invaluable tool in the Blockchain Developer Toolkit. So if you open Ganache, you'll see 10 accounts listed here. These are the addresses to each account on the side, and you'll see these balances. You'll see 100 Ether. This is the Ethereum cryptocurrency that each account has and is required to pay gas fees in the network and stuff like that. All right, so that's an overview of the Ganache personal blockchain network, and we're going to leave Ganache here set up in our project because we're going to need it running in order to develop our project. The next dependency is the Truffle framework. We're going to use the Truffle framework to develop Ethereum smart contracts with the Solidity programming language. You can install Truffle by going to your terminal and typing npm install -g truffle at 5.0.2. And it's important that you use this exact version in order to follow along with this tutorial. So Truffle is a suite of tools that allows us to, develop smart contracts, write tests against smart contracts, deploy smart contracts to the blockchain. It gives us development console, and it also allows us to develop client-side applications inside of our project. So it does a lot, and I'm going to show off all those features in this tutorial. The next dependency is the MetaMask extension for Google Chrome. Remember that the Ethereum blockchain is a network, and we need a special browser extension in order to connect to that network. And that's where MetaMask comes into play. MetaMask will allow us to connect to the blockchain with our personal account and actually interact with the smart contract that we'll develop in this tutorial. You can install MetaMask by going to the Google Chrome Web Store and searching for MetaMask and clicking install. And once you've installed it, just make sure that you enable it inside of your Chrome extensions like this. You can also see the little fox icon in your extensions tab. Now let's create the project. I'll start by creating a directory for our project like this. ETH just stands for Ethereum, so I'll enter into that newly created directory. And now once we're inside of here, we'll actually create a new Truffle project. But before we do that, I just want to make sure that you're using the correct Truffle version. You can check your Truffle version like this. Truffle version. And you want to ensure that your version is the same as mine, which is 5.0.2. So if it's not, go ahead and check out the dependencies section of this video to see how to install this specific version of Truffle. So now we'll initialize a new Truffle project like this. We'll just say Truffle init. All right, and now we've successfully unboxed a new Truffle project. And now I'm going to actually create a package.json file in order to, pull in some development dependencies for the project. So I'll say touch package.json. All right. And now I'm going to open this project inside of Sublime Text. That's the text editor I'm using. So let's go to the package.json file. We can actually see the project directory over here, and we can see the newly created package.json file, and it's empty. I'm going to paste in the contents of this file that we'll use for this tutorial. And you can actually get this package.json file by cloning this repository on the GitHub link in the description down below. All right, so here's the dependencies for the project. I'm just going to go ahead and save this. Like I said, I just pasted these in here. And you can see we have a few dependencies like the Bootstrap framework. We'll use this for building out the client-side application. We got some dependencies for testing the smart contracts, a server for running the client-side application, and some other Truffle-specific development dependencies. And I've locked these versions so that you can keep following this tutorial in the future. So make sure that all these versions match what I have here. So now I'm actually going to install the dependencies for the project like this. So just say npm install. All right, so now they're installed. Now let's go back into our project and actually create the smart contract file that we'll use to build the to-do list. We'll do that by going to the contracts directory. And you can see there's a smart contract that exists inside of here. This is actually a smart contract that comes bundled with Truffle that manages migrations to the network, and I'll explain that here in a little bit. And now I'll create a new file inside this directory called to-do-list.sol. So we can see that to-do list is capitalized to-do list, and it's in the same project directory here. So now let's actually create the smart contract that will manage the to-do list for the application. The first thing we want to do inside this file is actually declare the version of the Solidity programming language that we want to use. We'll do that like this. We'll say pragma solidity. We'll use a caret. We'll say version 0.5.0, and we'll end this line with a semicolon. All right. Now the next thing we do is actually declare the smart contract. We do that with the contract keyword. Say contract. And we want to call this contract to-do list, which is the same name as the file. Say to-do list. And we follow that with some opening and closing curly braces. And inside of here is where we actually write all of the code for the smart contract. Now I'll go ahead and bump the font up so that you all can see this a little better. So the first thing that we'll do inside of here is just keep track of the number of tasks that are in the to-do list. And we'll store this value inside the smart contract as a way to kind of get started and just make sure that everything is set up properly in our project. We'll deploy this simple smart contract to the blockchain and actually see if we can connect to it before we do anything any more complicated than that. So first, we'll keep track of the number of to-do lists inside of the smart contract with a variable. And it'll be a special kind of variable in Solidity called a state variable. And we can declare a state variable like this. We'll say uint task count. So state variables inside of Solidity are actually written to the blockchain. And that's what they're called, state variables. They actually represent the state of this smart contract on the blockchain. And the state of this smart contract is going to change anytime this task count changes. And these are a lot like, class variables in an object-oriented context where, the scope of the variable belongs to the entire smart contract and not necessarily like a function or something like that. We'll see that more as we continue on through this tutorial. But initially we can set this value to 0 like this. All right, we just say equals 0. And we can also create a way to read this value from the smart contract with a keyword called public. All right. And what that does is actually provide some function for us that allows us to read the value task count from the to-do list. And Solidity kind of just magically gives us a function whenever we use this public keyword. All right, that's all we'll do for our basic smart contract in order to set this project up and actually deploy this to the blockchain and make sure that everything's set up correctly. We'll come back and build this out throughout this tutorial, but for now we just want to do a simple check to make sure everything works properly. Now let's actually compile this smart contract before it goes to the blockchain and make sure that we wrote all our code correctly. We'll go to the terminal and type truffle compile. And we can see that it actually created some new files here. I'll show you that in the project. If you go to the build directory and then contracts, we'll see migrations and to-do list.json. So this is actually a JSON representation of the smart contract that was created by Truffle. And it contains some information that's useful to us. This is the smart contract ABI, which is the abstract binary interface. We'll actually use this later in the tutorial when we talk to our smart contract in JavaScript. We can see the bytecode that was created by the smart contract. This is actually the bytecode that gets run on the Ethereum virtual machine. And yeah, there's a lot more useful information inside of here, but I just wanted to show you that initially. Now, in order to actually put this smart contract on the blockchain, we want to create a few more files, and I'll kind of give you a tour of the rest of the project structure here as we do that. In order to connect to the blockchain, we'll actually need to update this truffle-config file, all right? And I'm actually going to just paste some code inside of here. Again, you can get this code from the repository for this project, the GitHub repo that I've got down in the description below. You can just check out that link. All right, I'm just going to save this. And I'll explain what's going on here. Basically, inside of this configuration file, we have the network's key inside of this object, right? So what that does is allows to specify several different networks, but here we have a development network that's actually connecting to Ganache. So this is localhost, and this is the port that Ganache is running on. So while we're here, let's go ahead and actually make sure that Ganache is running. So you can open Ganache, find wherever you installed it, make sure it's open. And we can see that the port is 7545, right? And we can see it's localhost 127.0.0.1, port 7545. So now that we have this filled out, this is actually talking to the local blockchain. Now let's create a migration file in order to get the smart contract onto the blockchain. So if you go to your migrations directory, you'll see a file inside of here. It's called initial migrations. So I'm actually going to copy the contents of this and actually create a new file in the same directory. And I'll call it to, and we'll say deploy contracts.js, okay? What's inside of this directory? Well, these are migrations. I'm just going to paste this code in here. So what is a migration? Well, if you've come from another development background where you've used a database, you might have had to change the state of that database by adding new tables or adding columns to the tables. And that's because you're changing the state of the database, the structure, right? The schema. And that's essentially what you're doing in this project right here with a migration. Whenever you're deploying a smart contract to the blockchain, you're actually changing the blockchain state. Remember, the blockchain basically is just a big database in one sense. And whenever you put the smart contract on the blockchain, you're updating the state, and thereby you need a migration in order to do that, okay? And you'll see these migration files over here are numbered, and that tells Truffle what order they need to be run in. So make sure yours starts with the number 2. And inside of here, what we'll do is actually change this. We'll change migrations to be to-do list. So to-do list from artifacts require, Truffle creates an artifact out of this to-do list.json that we saw a second ago. And that's going to be just an abstraction of the smart contract that it understands in order to put it on the blockchain. Now let's actually run the migration and deploy the smart contract to the blockchain. So first, again, make sure that Ganache is running. Make sure that you've configured this correctly. And we'll run the migration like this. We'll just say truffle, migrate. All right, it looks like it was successful. So what we've done is actually deployed the smart contract to the blockchain. And if you open Ganache, you'll see that something has changed. With this first account, we'll see that the balance of Ether, the Ethereum cryptocurrency balance, has actually gone down by a little bit. That's because deploying smart contracts to the blockchain actually costs Ether. It costs gas. And we can see that this account has done that. It's actually paid the gas fee in order to deploy the smart contract to the blockchain. And Truffle, by default, uses the first account inside this wallet in order to pay those fees. Now let's open the Truffle console in order to check the smart contract that we deployed to the blockchain. We'll do that like this. We'll say Truffle console. Now we'll retrieve the smart contract from the blockchain like this. We'll say to-do list equals await to-do list dot deployed. So to-do list is the name of the smart contract that we created in the migration. We can go back to the project and see, this to-do list, right? we've actually retrieved the smart contract, a deployed copy of it from the blockchain, and assigned it to this variable to-do list. And you'll see this await keyword here. So let me explain that. We must interact with the blockchain in an asynchronous fashion. And if you ever developed other JavaScript applications, you would know that there's a lot of different strategies for handling asynchronous actions, right? You can use promises. There's lots of different ways to do it. But with Truffle version 5, we've actually been able to use the async await pattern inside the console, which is really nice. You can just do things in a simple one line like this. Basically, this is just saying, wait for this finished result. And whatever the result is, assign it to this variable. So we can actually look at that. We can say to-do list. All right. We can actually see the result is the smart contract here. And I'll just pull this up so you can see. Let's actually get the address of the contract. We'll say to-do list, address. All right. And we can see this is the address of the smart contract that's deployed to the blockchain. This is just where it's located. And now we can actually see the count of tasks that we created in the smart contract. So we'll say to-do list dot count like this, or sorry, task count, I think is what we called it. All right, we can see that it's 0. And now Truffle actually stores that as a big number whenever we retrieve it. We could convert it to a number like this. We could just say task count. We could assign it to a variable and say await. All right, we can say task count to number. And I see that it's 0. All right, so that's a good check to see that everything is set up properly. If you've been able to complete all this so far, you've been able to create a smart contract, create a new Truffle project, connect it to a blockchain, and actually to put the smart contract on the blockchain and talk to it. If you have any trouble, just, rewind the video and try to see where you might have gone wrong. What we want to do now is actually pause and commit some of these changes. I'm going to create a new Git repository. I'll say git init. And inside of here, I'm actually going to create a git ignore file. You don't necessarily have to follow along with all these steps, but I'm just going to do them so that you all can see. What I'm going to do inside of here is create this git ignore file that ignores the node modules directory so that we don't commit all the node modules to source. All right, I'm going to say git add. I'm not sure what all these errors are. Sorry. I'm going to git commit. I'll say project setup. All right, so that's it for the first part of this tutorial where we've actually set the project up. In the next section, we're actually going to list out the tasks in the to-do list. Now let's list out the tasks inside of this to-do list. I'll show you the steps that we'll follow. First, we'll list the tasks in the smart contract, and then we'll do that in the console. And next, we'll actually wire up the client-side application and list the tasks there. And finally, we'll write some tests that make sure that the smart contract is listing the tasks correctly. So first, we'll go to our smart contract that we've been working on, the to-do list, and we'll actually write the code to list out the tasks in the to-do list here. So first, we'll need a way to actually model the task. We'll do that with something called a struct. Solidity allows us to define our own data types with structs, and we can create a new struct like this. We can just say struct task, follows with curly braces, and we'll actually give this some more attributes in a second. Let me pause and explain some more features of Solidity, right? Solidity is a statically typed language. In fact, you can see the data types listed here, uint. This is an unsigned integer, which basically just means that it's an integer that can't be negative, right? So integers can be positive or negative with a minus sign, a sign in front of it, or a positive sign. And so Solidity allows us to define this struct task here. And we can give it some attributes like this. We can say uint ID. This will be the ID of the task. And this is going to be an unsigned integer, which basically just means an integer that can't be negative, right? If it was a negative integer, it would have a sign in front of it. That'd be a signed integer, but this is unsigned. And the next thing will be a string, and we'll say the content. This will just be, the text. And next will be a Boolean, and that will be completed. And that'll represent the checkbox state of the to-do list, whether the item has been checked off or not. All right, so that's how we'll actually model a task on the to-do list with this data structure. And now we need a place to put these tasks. So where will they go? Well, we effectively want to put these in storage on the blockchain. So how do we do that? How do we access the storage? We need to create a new state variable like we did here with task count. Remember, task count is getting written to storage. It's a state variable. It's representing the state of the smart contract, which is written to the blockchain, the actual data storage. And we'll actually want to create a state variable called tasks here. But we don't want it to be, an unsigned integer. We want a different data type. We want something called a mapping. And this is going to take a key value pair like this. It'll say uint, say task. Okay. Now, a mapping in Solidity is a lot like an associative array or a hash in other programming languages where you store a key value pair, right? And when we declare this mapping here, we declare the data type for the key, which is an unsigned integer, and the task, which is, this struct that we defined here. And essentially, this is going to be kind of like a database for us. It'll have a uint, an unsigned integer, that will be the ID, essentially, of the task that we'll store here. So we can look for task 1, 2, 3, and it'll return the tasks, okay? And we also want to make this public, just like we did with a task count. And that will give us a reader function for free, provided by Solidity, that will allow us to access the items out of this mapping. All right, now we have a way to create new tasks and actually put them in the database or the blockchain in this case. We'll be able to use this task ID reference here and store the task like this. So now we need a way to actually put this task struct inside of this mapping. To do that, we'll create a function called create task. Say function create task. And inside of here, we'll provide a single argument, which will just be the content of the task itself. So we'll say string memory. We'll say content. Let's be public. All right. Now inside of this, we want to write some code that puts this task inside of this mapping. So the first thing we'll do is determine the ID of the task we're going to create, right? So that's why we're using task count. And you see that each task struct has an ID, and we'll want to increment this task count value anytime we're creating a new task to put inside of this mapping. So we'll do that like this. We'll just say task count, and we'll just use the increment operator. You might find this to be similar to other programming languages where you're basically just changing this value by 1. All right. So once we've done that, we'll have a new task count, which if this is 0, and the first time we call this, it'll change to 1. And that means the first task that we put inside of this mapping, whenever we call this create task function, will be 1. And the next time it'll be 2, and the next time it'll be 3. So now let's actually put it inside the mapping. We'll do that like this. We'll say tasks. That will reference the mapping. And we'll say task count. We can actually reference it by the key, which will be the unsigned integer here. And we'll just say equals, and we'll create a new task. We'll do that like this. We just say, task, just copy this. And we say task count. We just provide the arguments for the struct. So the ID, the content, and completed. So the task count is the new ID. The content is the content being passed in. From the function. And it's a new task, so it's not completed yet. So we'll just say false. All right. Now we have a way to actually put tasks inside the to-do list, which we'll need as a prerequisite in order to list tasks. We'll need some tasks inside of the to-do list in order to show them. And the next thing we want to actually do is, go ahead and populate our to-do list so that when we, call it up on the client side, it's already got some to-do items inside of it for us, okay? And what we can do is basically just add some tasks to this list whenever this smart contract is deployed. So how do we do that? Well, we do that with something called the constructor function for the smart contract. So if you've ever used another programming language that has like an initialize function inside of a class or some sort of object, maybe init or new, something like that, you've seen a constructor before. So basically, this is just going to be a function that's called whenever this smart contract is run for the first time, which in this case is upon deployment. All right. So inside of this constructor function, we can actually add a default task to the to-do list. All right. So we do that like this. We'll just say create task, and we'll just pass in check out dappuniversity.com. All right, I'll put a semicolon here. So now whenever we access this smart contract for the first time, it will have a sort of default task inside of it. So whenever we list the tasks out, there will be something there for us to see. And that way we'll know that this worked properly whenever we look at this in the console and connect our client-side application and write tests and things like that. All right, now let's actually compile the smart contract to make sure it worked. We could just say truffle compile. I'm going to have some syntax errors or something like that, and we'll see. All right, it worked. So now let's actually open the console to see if it worked. We'll say truffle console. Well, actually, first, before we do that, let's make sure we have Ganache running. I don't. So let's pull it up. All right, so Ganache is running. And now we actually need to migrate our smart contracts. We'll say truffle migrate. I'm just going to pass in the reset flag just to be safe here in case you had Ganache already running. So what does the reset flag do? Well, that would deploy a new copy of the smart contract to the blockchain if an existing one was already there. So like if you go, we change our smart contract code here. So if you added new functions or something like that, you could migrate with the reset flag to deploy a new copy. So I'm going to do that just in case you had Ganache running already. All right, now let's open the truffle console. So I'll do that like this, truffle console. And what we'll do is actually list out the to-do items. So first, I will just get a copy of the to-do list. We'll say to-do list equals await to-do list.deployed. All right, let's make sure the address is there. Say to-do list.address. Oops, misspelled that. Okay. Now let's actually list out the items. Now let me explain something about this mapping. We want to call this tasks function that's provided by Solidity to list out the task in the to-do list. And remember, we declared this public, so Solidity gave us a tasks function for free to reference this mapping. But whenever we call this function, it won't just return all the tasks in the list. And that's because Solidity doesn't do that for us. This mapping is a dynamic size. There's no way, natively to know how big it is inside the smart contract. And so you can't iterate over it, and you can't just return the entire thing. You actually have to reference the items out one by one. And that's why we're using the task count counter cache here. So if we know that this task count is 1, that means there's only one task in the to-do list, and we would just have to call this function one time to get that task, and we would pass in the ID, which would be 1 in this case, and it would return the task. But if it were 10, we would have to do this 10 times. We would call this function once with 1, and that would return task number 1. We'd call it the second time with 2, and that would return task number 2, etc., until we get to 10, which case it would return task number 10. And so that's how we would do that. And if you were doing that on the client side, we would use a for loop or something like that, which we'll get to whenever we reach that section. So for now, inside the console, we can just reference, the only to-do item inside of here, the only task is this one. So we can say task equals await to-do list dot tasks. We'll say 1. All right, let's see the task. Should bump this up. All right, there you go. So there's the task. We can see the content. Check out dappuniversity.com. We can see that it's completed as false. We can see the ID is 1. It's a big number, but we can actually do that. So inside here, we can say task ID, to number. All right, it's 1. task content. Sorry, it's not a function. It's just an attribute. All right, so now we've actually migrated this smart contract to the blockchain, and we've been able to list tasks inside the console. Now let's create the client-side application and actually list out the tasks there. So in order to do that, we'll need to create some new files. First, we'll create a directory to store the client-side files. We'll just say this. We'll say source. So we see a new directory came up here. And we'll create a new file inside of here called index.html. Sorry, let's say touch source index.html. And we'll create an app.js file to store all the JavaScript code. So say touch source app.js. Okay. So we can go to the project and see we have an empty app.js file and an empty index.html file. And another file we actually want to create is a BS config file. So BS config stands for browser sync configuration. And browser sync is something that we use as a part of light server. So if you go to your package.json file, you'll see this light server dependency. So this is the web server that we're going to use in order to run the client-side application. We need to configure the server to know about a few different directories inside of our project. We want to tell it where the source directory is for the client-side files. We want to tell it where these smart contract JSON files are. We also want to tell it where our node modules are to pull out some dependencies for building out the front end. So we'll do that like this. We'll actually create a new file, say touch bs-config dot JSON. Okay. So inside of this file, I'm actually going to paste in some code. And you can actually get this configuration from the project from GitHub down in the description below. So I'm going to paste this inside of here. And don't worry too much about this. This is all just proprietary browser sync configuration. So basically, we're just saying the server configuration is this, and we're pulling the files in from the source directory and also the build contracts directory. So basically, it's saying expose all of these directories to our web server root. And then also, we're going to mask a vendor with node modules. So any node modules that exist inside our project, we can reference those at the vendor route. All right, so there's our server configuration. And now we actually want to fill in the index.html file. Now, likewise, inside of here, I don't want to spend a bunch of time writing HTML and CSS, so I'm going to just paste in the code from the application. And again, you can just pull this source code from the GitHub link down below. I'm just going to paste this in like this. What we'll do is actually build out the JavaScript part, but I don't want to spend too much time writing the HTML. All right. So I'm going to paste this in here. I'm going to explain, what's going on. Basically, we're pulling in the Twitter Bootstrap framework to write the front end, so we don't have to write a bunch of CSS and UI elements ourselves. We can see this vendor Bootstrap. That was what I showed you a second ago in BS config. That's how I got this vendor here. And we can see some basic CSS that's just written inside the head tag. And yeah, we got some markup. Essentially, we have a simple loader to show whenever the application is loading. We'll have a form that allows us to create a new to-do item. And we will actually have a way to list out the tasks here. So for now, I'm going to just comment out this form, I think. I think it'll run otherwise. All right. And let's actually just see if we can start the server. So I'll start the server in a new tab. I'll say npm run dev, I believe, is the command. All right. Yep, that worked. So you can see that we basically got something, right? We see it's loading. That's fine. If you open your console, I'm sure you'll see some errors or something like that. Yeah, failed to load the resource. That's okay. Don't worry about that just yet. we will wire this up to actually work. But for now, I just wanted to make sure that the server is working properly, that we can see Bootstrap, right? We see this nav bar up here. We can see the Dapp University to-do list. You actually click through this link. It'll take you to my website, which is pretty cool. But yeah, so let's fill in the project and actually list out the to-dos in this client-side application. So to list the to-do items, we essentially want to fill in this unordered list. We've got two here. We have a list for the tasks and then the completed tasks. So if we have an uncompleted task, it'll go in this list, and whenever we complete them, it'll go here. But for now, they're all uncompleted, so they'll stay in this task list. All right, so in order to do that, we need to do several things inside this app.js file. This is where we'll actually create our JavaScript app that talks to the blockchain. So the first thing we'll do is actually create an app like this. Say app equals this object, okay? And we'll create a load function. And I'll actually call this async. We're going to use a lot of async functions inside of this tutorial. I've been using a lot of async await pattern when loading data from the blockchain. It seems to be pretty helpful. So we'll fill this in. And then in order to load the app, well, let's actually do this. Console log app loading. And in order to load the app, whenever the project loads, we'll just say window. When it loads, we'll just pass in a function. Say app.load. Actually, didn't mean to put that inside this object. Do that like this. All right, so let's reload. All right, so we can see the app's actually loading. All right, now I'm actually going to put these windows side by side, and you can see that this to-do list is actually responsive, which is cool. We'll be able to see the tasks right here and be able to focus on the code while we're doing this. The first thing we want to do inside this load function is actually say await app.load web3. We want to load the web3 library in order to connect to the blockchain. Now, when we load web3, I'm actually just going to use the configuration that's specified by MetaMask themselves, right? What we're doing is creating a way to talk to the blockchain. We want MetaMask, which is going to be the browser extension that we use to connect to our Dapp, our blockchain application, to talk to the blockchain with Web3.js. And MetaMask actually suggests a way to do that. So I'm not going to reinvent the wheel here. I'm just going to do what MetaMask tells us to do. So I'm going to actually just paste in the configuration that they suggest. And don't worry if you don't understand what's going on here. Just know that this works, and it's inside of the GitHub repository. And you can find the code and link with the link in the description below. So let me pause because I don't feel like I've fully explained Web3.js very well and what's going on here, okay? So remember, this to-do list application is backed by the blockchain. And we want to actually connect to the blockchain to use it. So a few things have to happen. We have to connect our browser to the blockchain, and that's what we use MetaMask for, right? And then our client-side application needs to actually connect to the blockchain, and that's what Web3.js is for. So inside of our project, we'll use the Web3.js library to talk to the Ethereum blockchain. It'll actually allow us to connect to it and, read and write data from the blockchain inside of the app. And then MetaMask will allow us to, communicate with that client-side application with Web3.js and allow us to, interact with it via our browser. So what we did here was just loaded up Web3.js, loaded our blockchain connection essentially. We could even call this like connect to blockchain if we wanted to. And now we'll actually use our browser to connect to it with MetaMask. So let's actually do that. I will open up Ganache. And let's actually find the private key here. We'll show the key. Copy it. All right. We'll go to MetaMask and make sure you've opened this if you haven't already. And what you want to do is connect to the private network, which is localhost 7545, right? So you might see the main Ethereum network first, but you want to change networks to localhost 7545 here. And what you want to do is click this accounts menu. You want to import account, and you want to paste in the private key. Select type, private key, and click paste, and then import. All right, I've already done this step, so I'm not going to do it. So I'll click cancel. Whenever you've imported the account, from Ganache, you want to use this. Make sure you use the first one because that's the account that we deployed the smart contract with. Okay. You'll actually be connected with that account to the blockchain, right? So here's your blockchain account, and then you can add it to your wallet in MetaMask to connect to the blockchain with your web browser. And you'll specify the blockchain by, picking this local blockchain that we have running with Ganache. Okay. So I'll refresh that. All right, and you've got your account connected to the network. Now let's take that account from Ganache, this one right here, and let's show it in our application to prove that we're actually connected to the blockchain with it. All right. So I'll just say load account like this. Create a load account function. Say load account. This will be async. And I'll say app.account equals web3 each counts 0. Okay. So web3 here was set by load web3. And it has this ETH object that's going to contain all the accounts, which will be an array. When you get the first one, which will be the account that we're connected with inside of MetaMask. And inside the load function, I'll say await load account app.load account. Okay, save that. And now inside of the index.html file, you'll see that we have a place for the account here. This will be the place where we can actually add the account. We'll do that in a second. But for now, let's actually just console.log and see if it worked properly. All right. Yep, there we go. We can see it here. We can verify that's the same account in MetaMask. So E925A, and that's E925A. All right. So we've successfully retrieved the account from MetaMask, and we'll actually stick it inside the project in a little bit. Okay, so we'll just clean that up. Now let's actually load the smart contract from the blockchain. This will be the to-do list that we created so that we can list out the tasks from the to-do list. In order to do that, we'll say load contract. So async. Pass it a function. And inside of here, the first thing we'll do is actually pull out the smart contract JSON file. So we'll say const to-do list equals await. We'll say jQuery get JSON. This will be to-do list. Okay. So if you remember, inside the bsconfig file, we exposed the build contracts directory to the root of our project, so we can call this to-do list.json file. We're actually pulling out this file right here, and we can log it. We can log it, but when we're to do that, we need to call this function. Say await app.load contract. Okay. All right, we can see it here. Here's the to-do list file. Okay, so next what we want to do is actually create a truffle contract. So a truffle contract is just a JavaScript representation of the smart contract that will allow us to, call the functions on it and things like that. So what we'll do is I'm just going to paste in some code that shows you how to do that. Do it like this. Okay. So this will be, we'll call it truffle contract. We'll pass in this to-do list JSON file. That's basically going to create a wrapper around the JSON file that we created by Truffle. And it's going to allow us to, interact with it. And we'll set the provider, which is the Web3 provider, which we created here. And this is basically just going to give us a copy of the smart contract in JavaScript. And it's going to tell us where it is on the blockchain. And we're going to be able to do stuff like, call all the functions that we coded inside of here, like the tasks function, the task count, and things like that. So let's clear this out and just save and refresh and see that everything worked. All right, so to-do list of undefined. Let's change that. So we actually need a place to store this contracts. So we'll say this. We'll say contracts like this. We'll actually create an empty object. Okay. We'll refresh. And if you guys get stuck on any of these steps, feel free to clone the repository and see the code below. Now we want to actually, get a deployed copy of the smart contract, like we did in the console. Remember we did, to-do list equals like await to-do list.deployed. We're going to do the same thing here. So we'll say app.to-do list equals await app.contracts to-do list deployed. Okay. And, this is really just, getting the values from the blockchain. So this is a live contract now. This is just like we did in the console. All right, now we should have loaded our app up with a lot of data. We've connected to the blockchain, we've retrieved the account, and we've retrieved the smart contract that we created, in the previous section. So what we want to do now is actually render some information on the page. The first thing we'll do is actually render out the account that we're connected with. So first, we'll just say render equals an async function. And inside of here, what I'm going to do is show the account, right, inside of our HTML. Okay. And remember, we got this place to show the account right here. So that's exactly what I'm going to do. I'm going to put the account inside of this. And I'm going to call the render function. So after the contracts have loaded, I'll say await app.render. All right. In order to see this change, we'll actually need to expand the window here. All right. We can see that the account was put in here. So like I said earlier, I created this as a responsive application. And we can see the account, here. But whenever we resize the window, we don't want to see that anymore, just to save some space. So we'll keep that down. But that works. And if you want to code this, with your window all the way open, feel free to do that. I'm just going to use a smaller view to save some screen real estate so that you guys can see both things happening as I'm doing the tutorial. All right. So let's do some more things inside this render function. What we actually want to do is render the tasks. But I'm going to basically create some other logic inside of here to prevent double rendering. All right. So what we'll do is do a couple things. We will say that the app is loading. We'll keep track of that like this. Let's change this to false. Whenever it's rendering, we'll say if it's loading, stop calling this function. This will basically prevent a double rendering problem. And while this is loading, we'll actually set it to true. And when it's finished, we'll put it back to false. So let's actually create a set loading function like this. I'm just going to paste some code in. You can find this code in the GitHub repository. So it's set loading. Basically, it's just going to update it. And we'll show the loader in the index.html file. This will be our simple loader that you see here, loading. This is loading. And I'm going to show it when it's loading, right? And I'm going to hide the content, which is this. This is actually the to-do list itself. All right, I'm going to show the loader, hide the content. All right, so let's save that and see if there's any errors. All right, so that looks like the loader went away, which is what we want. All right, now the next thing we want to do is actually fill in the tasks. We actually want to render them. So we'll list out the tasks inside of its own function like this. We'll say render tasks, say async. So inside this function, we need to do a lot of things. The first thing we want to do is actually load the tasks from the blockchain. And then the second thing we want to do is actually render out, each task with the task template. And we're going to have to basically render out each task one by one. And then we're going to have to actually show the task on the page. Okay. This is kind of a three-step process. And it's going to be a little complicated, but just bear with me. I'll show you how it works. So what we're going to do is fetch them from the blockchain, and And we're going to actually use this template that's created down here, this task template. It's going to have a checkbox in the content. And we're going to fetch this off the page and create a new task with this. Okay. So first, one thing we need to do is fetch the number of tasks from the blockchain. Remember, I said that we can't, just fetch all the tasks with this mapping. Essentially, we need to find out how many there are, and we need to loop through the items in this mapping and fetch them out one by one. So if there's 10 tasks inside of here, we'll need to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If there's one, we just do this once. So in this case, there's just one. But that's what we need to do. First, we say const task count equals await. This is app.todolist task count. Okay. And now we know how many there are. And the next thing we want to do is actually fetch this template that we'll use to list the task out on the page. Say const task template equals task template. Okay. And now we actually want to use this task count to render out each task on the page. So in order to do that, we'll create a for loop in JavaScript like this. If you've written some JavaScript before, this should look pretty familiar. We're basically just saying for every number from 1 all the way up to the task count, do this operation. So that's what we want to do. We start with 1 because that's the first valid ID inside of the mapping. So from task number 1 all the way up to the maximum number of tasks, which, if it's 10, we're going to do this 10 times. Fetch each task. So we'll actually read the value from this mapping with the ID. So I, in this case, is going to be the ID inside the loop. The first thing we'll do is actually fetch all the values for the task. We'll call the task function and break out the attributes to the ID, the name, and completed. We'll do that like this. So we say task equals await app.todolist task I, which is the ID in this case. And so because of how truffle contract works, this is actually going to return an array. And we have to reference these values by each item in the array. So the first item will be the task ID, the second item, which will be the task content, the third item, which will be completed. And remember, this array is 0 index. That's why the first item is 0. The second item is 1. Third item is 2. Okay. So now we'll have the task ID, content, and completed. The next thing that we'll do is actually create the HTML for the task like this. I'm just going to paste in this. All right. So what we'll do is actually get a new task template. We'll take this task template that was fetched from the DOM, and we'll actually clone it. Right. We'll get a new copy. We're going to find the content for this template, and we're going to fill in the content from the task. And we'll find the input, which will be the checkbox, and we're going to populate that with some values, which will be the task ID. So basically, whenever we check this, we'll turn it on and off. And whether it's completed or not, we'll just use that from the task. And we want to wire up a onClick function, which will be toggle completed. And we'll implement this later. We won't use it for now, so we can comment it out. Okay, so the next thing we want to do is actually put the task in the correct list. So I'm going to paste in some code here too. So what this does is check if it's completed. And remember, there's 2 lists here. There's a list for the completed tasks and a list for the, here's the completed tasks and then the list for the non-completed tasks. And if the task is completed, we'll put it in the right list. And the last thing we want to do is actually show the task. We'll do that like this. We'll just take the hidden task template that we've been modifying. We'll just show it like this. Okay. All right. So let's actually try to call this render tasks function inside of the render function. So render tasks is here. And then after we render the account, we want to render the task like this. So let's save this and see what happens. We might have some errors, but we can just address those as they come up. Oh, no. There it is. Boom. It worked. So we've actually successfully listed the tasks from the smart contract in the blockchain. I can pull this out, and we can see the first task inside of here, which is check out Dapp University. So I'm actually going to do that. I'm going to right click and go to dappuniversity.com. Awesome. So it worked. See my social links here. Get my Twitter. It's pretty cool. All right. So I know we've covered a lot of ground, but we have successfully listed the tasks inside the client-side application. Okay. I've commented a couple things out here because we haven't implemented them just yet. But if you get confused, just go rewind the video and find where you might have gotten lost. The next step we want to do is actually write some tests to ensure that the tasks were listed out properly. Okay. And we're actually going to use the Mocha testing framework from JavaScript and the Chai assertion library in order to write our tests. So you can read more about these if you want to. We'll create a new file in the test directory. We'll say test to-do list.test.js. If you go inside the test directory, you can see the to-do list.test.js file here. All right, so let's actually write a basic test to ensure that the contract was initialized properly and that it actually lists out tasks. The first thing we want to do inside of here is actually require the smart contract like this. That's very similar to our migration file pattern. We'll say contract, and we'll say to-do list. And we'll pass in a function here. All right, and we'll write all of our tests inside of this callback function. And this callback function is actually going to expose all of the accounts in the blockchain, right? So all the accounts that are connected to Ganache, all these, are going to be injected inside of this variable here. This will be an array. You can read them out one by one. So the first thing we'll do is actually get a deployed copy of the smart contract with a before hook, okay? And we'll do that like this. We'll basically just say before each test runs, that's essentially what this means. We're going to pass in an asynchronous function, which will allow us to use the await keyword. Let's say this.to-do list equals to-do list.deployed. Okay? And before each test runs, we'll have a copy of the to-do list that's deployed to the blockchain. Now let's create our first test example. We'll just say it deploys successfully. All right, we'll use the async function because we want to use await inside of here. And the first thing we'll do is actually just get the address like we did in the console earlier. We'll say const address await this to-do list address. We'll say we basically just want to make sure that the address exists. So we want to check that it's not empty. So we'll do that like this. Say assert not equal this address. We don't want it to be 0x0. We don't want it to be an empty string. We don't want it to be null, and we don't want it to be undefined. So we can check that, and that'll just make sure that the smart contract was actually put on the blockchain and that it has an address. Okay? Now we can run this test inside of Truffle like this. We just say truffle test, hit enter. All right, and it passes. Now, the next thing we want to do is actually list out the tasks in the test and make sure that it works. So we'll say it lists tasks. Pass this async function. So inside of here, we'll just do a very simple check. We'll just basically make sure that the count is correct and that we can fetch, a task by the count. So first, we'll just get the task count. And we'll just do that. And then next, we want to actually try to fetch the task out of the mapping. So we'll just make sure that a task exists where the task count is. Okay, this will be a simple test. So do that. And now what we want to do is actually assert that the ID is equal to the task count, right? That it was set correctly. So let's do a basic test and just try to run it and see what works. All right, it works. So let's look at that. You can see that we're just getting the task, we're calling the ID, and making sure that it's equal to the same task count. Next, let's test some more values and make sure that the content is correct, that completed is correct, and that the task number is the same as we expect. So let's just do that like this. I'll paste in some examples. We'll say assert equal. The task content is this. That's the first task we set whenever we initialize the contract. We want to say that the completed is false, right? We want to say that the task count is actually 1. We want to specify that it's 1 in this case. So let's say that, run the tests. All right, it passes. All right, so that concludes this section where we've actually listed out the tasks in the to-do list. I know that we covered a lot of ground. We actually created the tasks inside of the smart contract. We listed them out in the console. We had to wire up the client-side application to list the tasks out there, and we wrote some tests. So that's a lot. If you got confused about anything, feel free to rewind the video, paste in the code from the GitHub repository down below. And while we're here, I'm going to go ahead and commit these changes. I'm going to say git add. I'm going to say git commit. All right, so we've listed the tasks. The next item is to add tasks to the to-do list. We'll do this with a client-side application, and we'll write tests for it. But first, we want to change this create task function to add some additional functionality. So right now, we're calling this create task function inside the constructor to add a default task to the to-do list like this. But we want to, call this function externally from the client side in order to create tasks that way. We can also do it in the console and things like that. So what I'm going to do is actually add a new line here. And what I want to happen is to broadcast an event that this task was created. So let me explain that. Solidity allows us to create events that are triggered anytime something happens inside of a smart contract. And external consumers can subscribe to these events to know whenever the event happened. And events are really useful because whenever we call this create task function, we don't always know when, the transaction actually completed. We don't always know when it was mined and things like that. And it can be really useful to listen to those events in order to, know that it was finished. So we can create an event in Solidity. Before we call it here, we need to actually declare it inside of our smart contract. We'll just do it like this. We'll go below this mapping. We'll say event. We'll say task created. And notice that's capitalized. All right, use a semicolon here. And we'll just add some arguments to this event. We'll say uint ID. This will be the ID of the task that was created. A string. This is the content. And the completed property. So Boolean completed. All right. So that's how we create an event inside of Solidity, right? This just means that, the task created event is available to us inside of the smart contract. Now I'll show you how we can actually call it. We do it like this. We use the emit keyword, emit, task created, and we pass in the arguments. So the ID here is the task count and the content, which is passed in from the function, and false, because it's a new task and we haven't completed it yet. And that's pretty easy. That's how you trigger events inside of Solidity. And we can subscribe to these events, inside the client-side application or, anywhere that can listen to events on a smart contract. All right, while we're here, I'm going to go ahead and actually write the tests for creating the to-do item. So I'll open the test file over here, do this side by side, and I'll just create a new example down here. So below list tasks, we'll say it creates tasks. I'm just going to add some space so you can see better. So we'll say it creates tasks. All right, we'll say async, pass in a function. And first we'll say const results equals await this dot to-do list, create task, and I'll say a new task. Okay? And we'll check the task count. Await this dot to-do list task count. All right, we'll fetch that. And first we'll check that the task count is the same as we expect. We'll say 2. So that's the first thing we'll check on. We'll ensure that we created a new task and the new count is actually 2. And now what we'll do is check that this event, this task created event, was actually triggered. And we'll dig into the logs and say that the ID was the same, the content's the same, and completed was the same. So there will be the actually, this new task that we created was, logged out. So we can get the event like this. We're going to use this result, which was, the result of this finished create task function, right? We use the async await pattern to get the result here. And the event is actually going to be contained inside of that. So we'll say const event equals result logs. Okay, it's in their logs. And it's the first item. Okay. And the args key basically is going to contain all the values for the event. And you could log this out like in Ganache. You could actually console log this event. In fact, let's just do that right now. Let's just say console log result. Go to the terminal, truffle. We'll show you the result and what it looks like so you can see what we're digging into. All right, this is loading. Okay, so this is what the result looks like. We see there's a transaction hash here, and it's got a receipt. And inside of here, we have logs, right? And here is where the event information is contained, right? We can see this args key right here. It's going to have an object. And granted, we can't see exactly what's inside of here because it's not logging all the information. But this args key is going to contain all the values of this event that was triggered whenever this was created. Okay, so I'll take out that result. And now I will check to see that all the information is there. So we'll say assert equal event ID. We'll say toNumber. It's equal to 2. We'll say assert equal event content is equal to a new task. Assert equal event completed. We'll say false. All right, let's run the test. And this time we won't see all this log output. It'll actually just run the test and hopefully it'll pass. Yep, it passed. All right, so we can see that our event was triggered whenever we called this create task function. All right, so I'm going to remove this space. And that's how you write tests for this create task function and check on events. Now let's go to the front-end application and create tasks that way. Now, before you jump back into this, make sure a few things are correct. Make sure that Ganache is running, your blockchain is running, and make sure that your contracts are migrated, that you're connected with MetaMask right here, things like that. Okay, so what I'm going to do is actually enable this form that I commented out from the previous steps on the page. So this form is going to have an onSubmit function, create task, which we'll build here in a second. I haven't done that just yet, but I'll just refresh the page and show you what that looks like. All right, so we'll see this add task field, and we'll actually type in a task here, and we'll hit enter. There's no button here, just for simplicity's sake. We'll just use the enter key in order to create the task. All right, so I'll go back to the app.js file, and let's actually add the create task function. We'll do that like this. Let's do it down here below the render function. All right, we can say, oops, create task. This will be an async function. So what we'll do is say app.setLoading to true. Okay, so whenever we call this, we're going to show the loader. And what we'll do is a const content equals new task val. Okay, and that's just the name of the form. So if you go back to the index.html file, you'll see this, sorry, it's the name of the input. So on the form, see the onSubmit create task. We're going to fetch the value of this input right here, this input, which is the ID new task. Okay, and we're going to get the value, which is going to be what's ever filled out inside there. So new task value. And now we're actually going to call the smart contract function. We're going to call this create task function with Web3.js with the truffle contract library and talk to the blockchain in order to actually update it. So we'll say await app.to-do list. Actually, sorry, this will be create task. And we'll pass in the content from the value. Okay, And whenever we do that, whenever this is finished, I'm just going to do a shortcut and reload the page so that whenever this is actually done, I'll just refresh the page and it'll go ahead and fetch all the tasks from the blockchain again and list them out on the page. So instead of having to listen maybe for the event and then reload the page, like sometimes they can get into a double rendering problem. So I'm just going to actually just reload. So I'll say like window.location.reload. That's just a JavaScript thing to say refresh the page. Okay. So let's test it out and see if it works. I'm going to open the console, see if there's any errors. Nope, we're good. All right, so we'll say a new task, or we'll say task number 1. Task number 1. And like I said, there's no button here. You just want to hit enter in order to make this work. So I'll hit enter. And I didn't put a button on here just for simplicity's sake. I'll say confirm. All right, there we go. So we successfully added a task. We can see task number 1 was added to the list. And if you go and check Ganache, you can see the same thing. If you go back to your transactions, you can see that a transaction was created right here. I think it's the same one. Yeah, looks like that's the same one. And also you can go to your logs, see the same thing. You have to scroll like crazy. I think they're at the bottom, right? Anyways, that gives you an idea of where you can look to find out more information about the blockchain whenever you're doing this kind of stuff. All right, so we've successfully created a new task on our to-do list, and we've done it inside the smart contract. We have done it on the client side, and we've written tests to make sure that this works. So that's it for this section. I'm going to go ahead and commit these changes. I'll say git add dot git commit. Let's say 3 creates tasks. Now the last thing we're going to do in this tutorial is actually check off the tasks from the to-do list. Whenever we do that, they'll appear in a completed list down here and they'll be striked out. So we'll do that like this. First, we're going to go to our to-do list and we'll create a new function. We'll call this toggle completed. Okay. So I'm going to give you some space down here. Say function toggle completed. Okay, so what do we want this function to do? So we want to take this struct, these task structs that are inside this mapping, and we want to find a specific task, and we want to change this value. So if this value is already true, we want to change it to false, and if it's already false, we want to change it to true. So basically, if someone checked this item, it would say that it's completed, and if it's on the completed list, we could check it, and it would take it off the completed list and put it back in the not completed list. Okay. So this function will need a parameter. It'll need an ID of the task that we want to actually toggle. So we'll do that like this. We'll say uint ID. All right. We'll say public. So first we will get the task out of the mapping. All right. So we'll need to read the task out of the mapping like this. You can see task, tasks count. We can do the same thing. We say task, and we can read the ID like this. Say ID. So that will actually fetch it out. Let's assign it to a variable. Whenever we do this, we want to actually declare this variable with the type task. And we're actually going to do this just in memory. So it looks kind of funny, but this is how we do that in Solidity. We say task. This is the data type that we declared right here. Task, memory, and we say task like this. Okay. Now notice this underscore basically just means this is a local variable and not a state variable. That's not necessarily specific to Solidity. It's just a convention, right? You see this here. In fact, I'm going to do this like this as well. ID. You see, content is underscored here because that was a local variable that was passed into the function. ID is the same way, and I'm going to do just task like this because I don't want to assign it to the state. There's nothing special about doing that. It's just convention. So now I'm going to say task.completed. And we basically want to do the opposite of whatever it was before. So we can read the value of whatever it was before like this. We just say tasks completed. But we want to say the opposite. So we'll say bang. Oops. Bang. Right? So if it was false, this will turn into true. And if it was true, it'll turn into false. We're assigning that new value here. All right, next, we're going to put it back into the mapping. So just like we did tasks, task count equals this, we're going to put it back into the task mapping. Let's say tasks ID equals task. All right. So that's how we would create a function to toggle task completion. Now, I want to do a few more things inside of here before we move on. I want to emit an event just like in the create task function. So first we'll declare an event. We'll just say event, let's say task completed. All right. And we'll give this 2 arguments. We'll say uint ID. Say uint, bool completed. All right. And now I will trigger that event inside here. Say emit task completed. Say ID task completed. All right. And that should work a lot like our create task function, where that will emit an event anytime this function is called. Okay, so let's actually write a test to make sure this works before we, wire up the client-side application. We'll go to the test file right here. And I'm actually going to split this pane vertically. All right, so I've just split this pane. We've got a test file down here and the smart contract code up here. So I'm just going to focus on this. We want to just test this function, unit test this, toggle completed. So I'm going to create a new function down here. Give ourselves some space. A new example. That will say that it toggles tasks as completed. So I'll scroll down a little bit. I'll actually just copy this and paste it again to give ourselves some space and have some boilerplate. So we'll say it toggles task completion. And I'll clear out all this. Actually, let's do this. Let's say result equals this dot to-do list dot toggle completed. And I'll pass in 1, which would be the first task. And we'll get the task itself. We'll actually retrieve the task. I'll pass in ID 1. All right. And we want to assert that that's going to be equal to task completed. We want it to be true. And we want to fetch the event just like we did in the previous example. And we want to ensure that the event ID is equal to 1 and that the event completed is equal to true. All right, does that make sense? So basically, I know I modified a lot of that code, so that might be a little tricky. I didn't just write it out as I was thinking it. I just changed what was there from the previous example. So let's just review. So we're toggling completed. We're calling this function. Passing in the ID of the first task. We know there's a task already in the to-do list because we created one inside the constructor, right? And we waited for that to finish. Got the result, which we'll use to read out the logs here in a second. But the next thing we did was we got the task, right? And we checked that it was actually completed, right? So that's true. And now we wanted to make sure that this event was triggered. And we get the event by digging into this result, which we witnessed in the previous section. If you didn't check that out, go ahead and rewatch that part. So we took the event and got the ID, made sure it was 1, and then looked at completed and ensured that it was true. All right, so let's try to run the test. All right, so it looks like that had an error. Let's go back to this code. We can see I forgot the underscore here. Let's run it again. All right, it passes. Awesome. Okay, so I'm going to remove this space, save this. Now let's go to the client-side application and wire up the checkboxes to toggle the tasks. So go back to the app.js file, and I'll create a new function down here. We'll call it toggle completed, I believe. This is the same name as the smart contract function. So below create task, we'll say toggle completed. I'll say async, pass it a function. And what we'll do is similarly to create task, we will say the app is loading. We'll say const task ID. And actually inside of here, this is going to be on a on-click event, because whenever we click this checkbox, we're going to have an event listener that calls this function. So I'm going to pass in the actual event itself. We'll just use an E for short. And that event's going to contain the name of this checkbox, which the name value is going to be set to the actual task ID. So we'll say e.target name. And now I'll say await. When I'm actually going to call the smart contract function to toggle this task is completed. We'll say app.to-do list. Toggle completed. I'm going to pass in the task ID. All right. And then just like the create task function, whenever that's finished, I'm just going to reload the web page. Put a semicolon, or sorry, a comma there. Okay, no errors. But if you remember in the previous sections, I commented this out. So I'm going to re-enable this. This is where we actually wire up the on-click handler to do this. So now, whenever we're rendering the tasks out, we found the checkbox, and we want to actually add the event handler whenever it's clicked to call this function. So everything looks good. All right, let's try it out. We'll try to check this off the list, see if it works. All right, looks like we got a problem here. All right, we do have a problem. And I'm going to see if you can guess what it is. It's something I forgot to do in the previous step. And I'm actually going to leave this in the recording because it kind of shows you the nature of blockchain development and all the things you need to do. Do you know what it is yet? Well, I'll tell you. We forgot to run the migrations. So we added a new function to the smart contract, and it worked in the tests. But we didn't actually deploy a new copy of the smart contract to the blockchain with this new function. So in order to do that, we'll run truffle migrate -- reset to deploy a new copy of the smart contract to the blockchain. And whenever we do that, we're going to want to refresh our web page to pick up that change. All right, so let's try that again. Sorry, guys, I forgot that step. Like I said, I wanted to leave that in the video just to show you, something you might forget to do, and hopefully that'll help you remember. All right, so we'll refresh the page. Now we see that our other task is gone. Now, why did that happen? Well, that's because, whenever we deploy a new copy of the smart contract, all the state of the smart contract is gone, right? It's a new smart contract whenever we redeploy. So all the old tasks we had in the smart contract have disappeared. So we'll add a new one. Let's say task number 1. We'll add a few. We'll just sign these really fast. Task number 2. So task number 3. All right, so now let's actually toggle when it's completed. And we see the MetaMask confirmation pop up. We'll sign it and confirm. And there we go. We've actually successfully checked off task number 1 from the list. And we can see that it was added to the list down here below. So we can actually do the to-do item on task number 2. We can go to dappuniversity.com. All right, we see it. Awesome, we went there. And now we can go here and check that off the list because we actually did it. Confirm. And there we go. All right, so that's it, guys. That's actually the end of this tutorial. You've successfully created your own to-do list on Ethereum powered by smart contracts. And you've created this client-side application to interact with it. So congratulations. So I hope you all like this tutorial. Again, be sure to subscribe to the channel if you haven't already. And also, don't forget, you can download my courses for free on my website over here at dappuniversity.com/free download. You can just sign up for my email list to get my courses downloaded for free. And also, you can keep up with me on Twitter and stuff like that for more daily updates. So also, guys, I'm releasing a premium course, like a full decentralized blockchain development course sometime soon. So you'll want to sign up to that email list to find out more updates about that. It's going to be really extensive. It's going to be really awesome. You're going to want to learn about it. So just stay in touch. And also, by the time this video is out, you'll be able to find an article to accompany this video, which you can follow along step by step. It'll be somewhere on my website. It'll probably be in the video description below as well. You can see other articles on my website here. This is the Ultimate Ethereum Dapp tutorial, which I released last year, which is a pretty popular tutorial that shows you how to build your first decentralized application. You can code your own cryptocurrency on Ethereum. Build an ERC20 token and stuff like that. We've got some other deep dives on topics like, Web3.js, which we talked about some in this tutorial. A lot more lessons on Solidity, how to develop smart contracts. I kind of go into more features of the language and things like that. So this is a huge resource with a lot of free stuff, a lot of good information. I also have some tutorials on like how to build a real world ICO and things like that. This is like a production ready ICO that you could use in the real world. This is pretty advanced. And also if you're looking for somebody to work on your blockchain projects, I am available. My email address is down below. I do a lot of, blockchain development, a lot of consultation and advising for people who are launching blockchain startups, ICOs, things like that. I've got a complete solution for launching an ICO. Like I said, you can reach out to me via email. My email is on my website and also in the description below. Some buttons here. You can contact me on the website. Like I said, my Twitter's here, things like that. So again, I hope you all liked this tutorial. And until next time, thanks for watching Dapp University.